Hello there, folks. Joe was here today. Just want to make a quick video today on a couple concepts I'm doing here. I've got this radar sensor, ultrasonic sensor from Banner Engineering, which puts out a 4 to 20 milliamp signal, and I have it connected to one of the SnapSignal devices. This one right here with the S15C-I-MQ, and this one will convert the analog signal into a Modbus register, and then I have that wired to an E3, and I'm using the RS-45 ports right here on the E3 to read that analog signal, and then my goal is to put that on a Modbus TCP holding register. So that's what I'm doing in this quick example. Let me show you the Crimson file that's currently running. So here's the E3 database using Crimson 3.1. I'll just go through these tabs. I'm not doing anything here. On the network tab, I've got it set up with this IP address. I'm not using Ethernet 2. I'm downloading here, nothing there, and I'm not doing any changes under this. I'm not using the 6net or Modbus setup here. All I'm doing is under the RS-45 port, I've got chosen the Modbus master, I'm doing the protocol ModbusRTU, these settings here, and then I've got the baud rate 19200, 8, 1, and none, which is standard with the SnapSignal. And then I have under here the device. This here is actually the SnapSignal. So the default name is dev1. Let's just call this SnapSignal. We'll just rename it right now. You know what? And let me give this a underscore 1 here because this is drop number 1. And then below there, I've added a analog transfer, which is right here. And what I'm doing is I'm doing device to E3. So it's going to take from the SnapSignal into here. I'm doing a block of 1. And this is going to sound really weird, but the source is going to be A0, which is going to look at Modbus Holding Register 40,001 here. And then my goal is I want to put it into an analog input register in the E3 at address 21. Now you might ask, where did I get the address number here, this 21 or so forth? Well, if I go over here to I/O channels right here, you can configure the different channels that are on here. This is a mixed module, so it's got analog and discrete, and you see here, you can change them. But if you click right here on the I/O channels, right here in the I/O channels, it'll show you the Modbus mapping. It's not very clear, but the Modbus mapping for this. So if I slide down into here, and you can see the analog inputs, the first 8 are dedicated to the 8 channels, and apparently there's some counters in there. I don't know how to work with those. But then there's some free registers. So you see free registers is 21 to 256. So if I go back to my communications, my block, you can see that I'm going to take this holding register from the SnapSignal, and I'll put it in AI register 21. So that's what we're doing on this particular demo. And I have, that's the parts here. So if I go over here to the web page from this unit, and if we look down here at 21, give it a second to update here. Well, oh, there it went. There it goes. Okay, so you can see the number right there, and I'm holding this ultrasonic or this MU gauge up to different targets, and you can see the values change accordingly there. So that's the U gauge going into the S15C-I for current-MQ SnapSignal slave 1, and there's the mapping of that number. And of course, if I hold it, point it way off in the distance, it'll go full scale. If I kind of point it at the PC, you can see the numbers always change. And the fastest you can update here is 3 seconds. So that's that there. And then I want a step further, team, and I'm using my awesome PLC analog current simulator, this particular unit. And on this guy, I've got the black wire here, from here connected to 24 DC. The red wire is going into analog input 1, which is on here. So if I go back to the web page here, you can see right now it doesn't show anything. Let me turn my simulator on here. All right, so I got the simulator on right now, and it jumped for some reason. I don't know why I did that. But currently I'm putting out 0 milliamps. Now the channel is configured as 4 to 20 by default. I believe that is correct. If I go back over here, check my I/O channels, click here, they're all set 4 to 20 here. Okay, so in that case, as I ramp the volt or the milliamp up here, I'll get to 3 milliamps. There's 3. Watch what happens when I get to about 4. We're looking to see if we get AI1 here. There we go. So you can see the number right there. And if I ramp it all the way up to, say, 20 milliamps, let's see what that number jumps to. Going on up here, close. 20 milliamps is the max. So this is acting basically as a signed integer. It apparently goes from 0 to 32,767 for the max between 4 to 20 milliamps. So that is how that works. The important thing here in this demo is over here in communications. Well, you can do it here in the web server as well, but I like to use Crimson. That way it stays in the database. Communications here, you notice I'm going device to E3, block size 1, and again, this is the source coming from the SnapSignal, and this is where I'm putting it. And I have to put it in register 21 or some higher, because if I go over here to I/O channels and click on I/O channels, down here on analog inputs, the first 20 are allocated, so you have to go to 21 and greater for that to show up. Anyway, I just wanted to show off a quick video of that, how that works, and works pretty well. By the way, the wiring, I should make a better video for the wiring, but I just wanted to quickly get this out there. The wiring on the 45, the black lead is the 45 minus, and the white lead out of the snap signal is the plus signal for your 45 comms. Anyway, hey, thanks a lot, folks. Have a great day.